Welcome to Creative World. In this video, we will solve Chapter 3 Learning Assessment E3.5. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Learning assessment E3.5. Find the voltage V0 in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find voltage across this 12 kilo ohm resistance labeled as V0. So without wasting time, let's proceed towards the solution. We will solve this problem using nodal analysis technique. And we know that in order to apply nodal analysis on a network, we have to follow some steps. First step is to count total number of nodes present in that network. In our case, there are 3 number of nodes present in this network. One of them is reference or ground node. Other 2 nodes will be utilized to apply nodal analysis technique. In second step, we have to label all node voltages. In our case, voltage of this node is already given in this scenario, that is Vx. So we have to just assume this node voltage. So we will label this node voltage as V1. Third step is to assume all unknown branch currents along with their directions. In this network, these 3 branch currents are assumed as current I1, current I2 and current I3 along with their directions. These currents are leaving from these 2 nodes and entering towards reference node. We have followed all steps of nodal analysis technique. Now we have to implement Kirchoff's current law on this node. KCL equation of this particular node will be only one current is entering, that is 2 milliampere, while 2 currents are leaving. One is I1 and other one is the current of this dependent source, that is Vx divided by 6000. Now we have to find the equation of current I1 and replace this variable I1 with that equation. Current I1 will be equal to voltage across this 3 kilo ohm resistance divided by the value of resistance. In this case, voltage across this resistance is Vx, while the value of resistance is 3 kilo ohm. So I1 will be equal to Vx divided by 3 kilo ohm. In this equation, only one variable exists, that is Vx. So we can calculate its value. But before that, we have to omit all denominator values. If we multiply this equation with 6000 on both sides, the denominator values can be omitted. Product of 6000 and 2 milliampere will result 12. Similarly, product of 6000 and Vx divided by 3 kilo ohm will result 2Vx. 6000 divided by 3 kilo ohm will result 2 and that 2 will multiply with Vx. Here the product of 6000 will cancel out with 6000 in denominator and only Vx will left. Add minus Vx and minus 2Vx together because both have same variables. So their sum will be equal to minus 3Vx, and in order to make it positive, place minus 3Vx on the other hand side of equal. The equation will become 12 equal to 3Vx. Here we can calculate the value of voltage Vx by dividing on both sides with 3. So the value of voltage Vx will become 4 volt. After getting the value of voltage X, we can calculate current through this dependent source, that is Vx divided by 6000. So the value of current through this dependent source IDS will become 4 volt divided by 6000. Now we will apply Kirchoff's current law on this node to calculate the value of voltage V1. Kirchoff's current law equation for this node will be only one current is entering, that is 4 volt divided by 6000, while other 2 currents are leaving from this node I2 and I3. Entering current is taken with positive sign and leaving currents are taken with negative sign. Now in next step we have to find the equations of current I1 and I2 and replace these two variables with their equations. Current I2 will be equal to V1 divided by 12 kilo ohm. Similarly, current I3 will also be equal to V1 divided by 12 kilo ohm because both resistances have same values and both have common node V1. So equation will become 4 volt divided by 6000 minus V1 divided by 12 kilo ohm minus V1 divided by 12 kilo ohm equal to 0. Now in order to further solve this equation, we have to omit all denominator values, and these values can be omitted by multiplying 12k on both sides in this equation. Product of 12k and 4 volt divided by 6000 will result 8 volt. 12k divided by 6000 will result 2, and that 2 will multiply with 4 volt, so it will become 8 volt. Similarly, product of 12k will cancel out with 12k in denominator, and same case will be here. Only V1 will left. Now this minus V1 and this minus V1 will become minus 2V1, and place this minus 2V1 on the other hand side of equal to calculate its value. Divide on both sides with 2 to calculate the value of V1, that will become 4 volt. And if we observe, this V1 is appearing across these two resistances and both are connected in parallel connection. So we can say that V0 will also be equal to V1. So the value of V0 will also be 4 volt. So this was chapter 3 learning assessment E3.5. Thank you. See you again in next video.